Personal finance practice problem using OneNote. Monthly loan payment calculation and amortization table. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab down in the 1215 Monthly Loan Payment Calculation and Amortization Table tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our presentations will also be in the text area. Same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculations on down below. We're looking at the payment for some type of loan, a typical kind of loan scenario for the personal finances being financing equipment, financing a car, financing even a home type of calculation. First step, figuring out the payment option for it, or estimating what the payment would be if you're thinking about your financing options, and then building the amortization table. Amortization table giving you a better perspective of the breakout between interest and principal on a period by period, month by month, as well as year by year basis, also helping you to determine possible tax implications related to it, as interest might be tax deductible, for example. So last time in a prior presentation, we did a similar problem, but we were breaking it out on a year by year basis to kind of simplify the calculations. This time we'll do what would be more likely to happen in practice, which is a month by month payment, which will complicate the type of calculation a little bit, and it will also result, of course, in a longer table when we put together the amortization table, which looks overwhelming, but is quite easy to put together due to the fact that we could just copy it down if we're using something like Excel to do that. We do this problem in Excel, so if you want to work it in there as well, you can. So we have then the borrowing. We're going to imagine we're going to borrow the $11,000. The interest rate we're going to imagine to be 12%. Remember, when we're looking at the interest rate here, usually we'll be quoting the yearly rate. And that's one of the key things you got to keep in mind. A lot of people don't really conceptualize that fact that when someone quotes a rate, they typically mean the yearly rate, even if you're going to be applying that to some other format of payment. So for example, if you're financing a car, financing a home, you're going to be paying it off on a month by month basis, but the rate that they're going to quote to you is usually going to be a yearly rate. Notice we used a fairly high rate here of the 12% compared to what we've seen in the past, and part of that is because we want to see how we could use the tables as we work this out as well. Note that if we break this out to a monthly rate, we'd have to divide by 12, which would give us a nice even 1 to allow us to work with the tables. If you're in a school setting to work with tables and they take away your Excel, they take away your calculator, they're going to be limited by the tables, and that's why they kind of stick oftentimes to a year-by-year calculation instead of going into the more fine month-by-month calculations. And when they do so, they're going to have to be severely limited due to the tables needing even numbers in terms of both the percents and the years or periods involved. When you do this in Excel, there's no limitation for that, and so we'll note that as we go forward. We're going to see it's going to be repaid in 3 years, and that means that we're going to make monthly payments. So if we take those 3 years times 12, that's going to give us our 36 payments. So we're talking 36 periods, this time monthly periods, and that would add up to 3 years. So let's first think about this in terms of our payment calculation. If you've done this in Excel multiple times, then you would say that's the payment type of calculation. But if you have an idea of present value, future value calculations, you might first have present value calculations in your mind, and it can be useful to just jog your mind by first typing in the present value, remembering that these functions you can kind of back into any of the one unknowns if you use something like GoalSeek, and then you can move forward from there and maybe using the payment function or possibly using GoalSeek to complete the process. So let's do that first. Negative present value, the rate would then be the rate of the 12%. Now that would be the yearly rate, so we need to divide that by 12. So I do that nicely into the formula here. Note that Excel doesn't care whether it gets to a nice even 1% as it does here, which does matter in the tables. You can use whatever it is. If you're 5% a year divided by 12, and you get some messy number that's going to be below 1% and so on. Not a problem in Excel. We'll just put the formula in. And then we're going to say comma, the number of periods. Now the number of periods is not 3 years. We got to make sure that we pick up the months, which would either be this cell, which would be the 36 months, or you can pick up the 3 years and then multiply it as we did here times 12. And then we're going to say comma, the payment is going to be the amount that is the unknown, and that's going to be a monthly payment. And so note here, it says payment in the Excel formula, which might tell us at that point and say, maybe Excel has another formula that's called equals PMT that stands for the payment, and we could then use that. And or we could say, why don't I set up another cell down here that I can use for the goal seek, estimate what the payment would be, estimating like $1,000 or something like that, and then allowing Excel to change it to whatever it needs to be to get to the end result we need to be. In that way, we can kind of use our algebra in a way, solving for one unknown in the equation. So the end result then is going to be the 11,000 if it were a present value calculation, because that would then be the present value or the loan amount. And then you can ask Excel to solve for this one, which would be the payment, and say, Excel, would you adjust this to whatever it needs to be to get the end result to 11,000? Or you can say, why don't I see if Excel has the payment function down here? And then Excel will basically do the algebra in essence for you, solving for the payment function down here. And that would look something like this. We got the negative payment. I'm putting a negative for the same reason as I did with the present value and future value. It'll flip the sign if we don't have a negative. In other words, it'll result in a negative number. The negative will flip the sign to result in a positive number. And you could put that in front of the present value, which is probably more proper, but I like putting it in front of the entire thing. Then it's going to be the PMT brackets. The rate is going to be, once again, the 12%, but that's the yearly rate. We're going to divide it by 12 to get the monthly rate, which this time is nice and even at that 1%. But note, I don't even need to know the percent here. I could just take the yearly percent and divide it by 12. Comma, the number of periods is 3 years, but it's not at a yearly period. It's 36 months that we want. We can do that by taking the 3 years times 12. And then we're going to say comma, and the present value is going to be the loan amount of the 11,000. That will then give us the payment of the 365.36. Once we have that number, then we can set up our amortization table. And remember, if you're working with a loan financer or something like that, they're usually just focused on this number, and then they're going to try to focus on your budget, and they're going to act like the only things that matter is whether or not you can make the payment or not. But that's not the only thing that matters, because you want to know how much you're actually paying in terms of interest and whether that's going to be a fair amount of payment in terms of the interest, which they can manipulate by having the loan go longer and so on. And you also possibly want to know how much interest you're paying versus principal on a period by period and year by year basis, especially if you're going to have to pay taxes on it or if there's any tax implication related to it. So for that, you can build your amortization table, which we did in the past on a year by year basis. This time we're just going to do the same thing on a month by month basis. Notice it would be quite a long amortization table here, which means it would be difficult to ask a question like this if you were doing this in a test question. But it's something that you can easily do in Excel, and a test question might ask you, if you're in a school setting, for the first couple payments related to an amortization table. Remember that the amortization table will basically be the most difficult part if you're building it under pressure, is to come up with the correct headings, especially if you have to do it by hand and you got to erase it and so forth, if you have the wrong amount of columns and that kind of thing. So if you're doing it and you have to set it up by hand in a test question, just make sure you got the headings lined up so you can do it properly. Once you have a template in Excel, they're pretty easy to build out. So we got the 11,000, and then we got the payment. The payment I'm just going to be picking up from up here. It's rounded in our table down here, so keep that in mind. The interest then is going to be the 11,000 times the 12%. So there's a couple ways we can do this. 11,000 times 12%, that would be per year, and I can divide that by then 12 to give us the monthly amount of 110. Or I can take the 0.12, 12%, divided by 12 to give us the monthly rate, which is 1% times 11,000. Now, when I do this with a calculator, I like to do the first method better, because if it's a small rate or percent, it could be a little confusing to do it that way. When you do it in Excel, notice our formula took into consideration that it calculated this monthly rate. So you got to kind of see it that way so you can do the functions in Excel. So then we're going to have then the 365, that's the amount of the payment minus the interest, which is kind of like the rent on the purchasing power. It just goes away. It's not going to decrease the loan balance here. The interest will not. 365 minus the 110, that's going to give us the 225. Then our loan balance is going to be the 11,000 minus the 225. That's going to give us our 10,077. Let me do that one more time. We got the 11,000 minus the 255. That's going to give us the 10,745. We could do that again. We can take that 10,745 times the 0.12, and that would be for a year. Divide that by 12. That would be our interest. So the payment's the same, 365. We got the interest then at the 107, slightly less. Notice there's a much different or smaller distinction here than when we had a year-by-year basis, because, of course, now we're talking about smaller month by month, but we still see that same change. The payments staying the same, the principal going down, therefore the interest amounts going down, and the loan decrease is going to be going up as we move forward. You can also do this calculation by taking the 0.12 divided by 12, 1% times the 10,745 to get that as well. We subtract these two out. We're going to take the 365 minus the 107. That's going to give us the 258. Then we can take that 10,745 minus the 258. We get the 10,487. Taking that, we got the same 365. We can multiply it times the 0.12. That would be the interest if it were for a year, divided by 12. That'll give us the interest for the month. We can also calculate that as 0.12 divided by 12, 1% the monthly rate, times the 10,487. Get that same number. Then we're going to say that we have the 365 minus the 105. Gives us the 260. Our loan balance then will be the prior balance, the 10,487 minus the 260 for the 10,226 about, 10,227 about. One more time. We got the 365. We've got the interest, which would be the 10,226 about times 0.12. That would be the yearly interest divided by 12 gives us the monthly interest, which we can also calculate by taking the monthly rate divided by 12 to get, the yearly rate divided by 12 to get the monthly rate of 1% times the 10,226, which will also get us the interest calculation of that 201. We can then take the 365 payment minus the 201. That will give us our loan decrease of the 263. The prior balance, 10,226 minus the 263, will then give us new loan balance of the 9963. Now, this is a tedious process, but you can simply copy this down in Excel. So we just copy this down the whole way. And if we do it properly, then at the end of the day, we can double check it by having this end number should be 0, because everything should be paid off. Loan balance should be down to 0 at the end of the 3 years, the end of the 36 months at that point. Notice at the very end, your breakout of interest is much smaller. We're only paying $4 in interest. Most of it is principal at the end when we're paying the same amount of the 365 monthly, as opposed to the first payment where we paid $110 of interest. So big difference on the interest spread. Again, that's the change. That's the difference that you're going to have, or the price we pay, in other words, for having a nice even payment, because then the interest and the principal will differ as the loan goes forward. That also means that if you have tax implications involved, then you usually get to deduct the interest, not the principal payments, as the loan proceeds forward. So you'll have a varying tax impact, from year 1 to year 2 for the same loan. And you can basically add up the interest per year by adding up the 12 months to see what the yearly impact will be on the loan as well. Also note that when you do your accounting for this. You need the amortization table because when you make the payment, you got to allocate the interest expense of the 210, for example, the loan decrease of the 255, which will give you the ending balance in your books of the 10,745. Now, you can also do this with tables down here. This one will be more difficult with tables, and you can see severe limitations if a test question tries to use a tables with the monthly calculations, and let's kind of see why. Normally, our calculation here would be the payment times the table amount gives us the present value of the annuity. If I know what the present value should be, the 11,000, then I know what the table is. I can back into the payment. So I'm going to back into this yellow amount up there. I'm going to look into the table, but I can't use, when I look at the table normally, the percents have normally been yearly percents, and the periods have normally been yearly periods. But now the periods are monthly periods, and therefore the percents need to match the monthly periods. But the table only goes down to, notice it goes down to like, we've got the 30 and then it starts skipping periods, 30 to 35 to 36 to 40 to 50. So we start having limited periods down here once we get above a certain threshold. Notice we're only talking 3 years out. So you obviously can't do something like a home loan, which are monthly payments for 30 years, which would be 360 periods, monthly periods. You can't use a table for something like that, of course. And they're going to be limited with regards to the rates, because when I start talking about monthly rates, anything that's under 12%, right, on a yearly rate, if I divide by 12, is going to be less than 1%. So I can't use the table for anything that's going to be less than 12% if I'm trying to convert from a yearly 12% or less than 12% rate to monthly rate. And any percent that's going to be a fraction of a year, is a fraction of a percent on a monthly basis, also doesn't work. So notice what we did here. We used a nice even 12%. You can see how severely limited, if you're forced to use the tables on a monthly kind of component, you have to use like 12% or 24%, so that when you divide it by 12, it's going to be 1 or 2 and not some uneven number. And you're forced not to use or go too far over, or at least be limited by the number of periods that you're going to have as well. Okay, so if the yearly rate is 12, the monthly rate will be 1. 12 divided by 12 or 1, and we got 36 periods. So we'll look up, we're going to say 1 on the percent, 36 periods. That gets us down to 30.108. So there's the 30.108, and then we can back into the yellow number. I can say, okay, well, if the end result is 11,000 divided by 30.108, that should get us about to that 365.35 about. We can double check that by then saying, okay, the 365.35 times the 30.108 should give us about then the 11,000, noting again that, of course, the tables will be rounded, it looks like, to 3 to 4 digits.